All right. So, properties of logarithms. Now, properties of logarithms is a pretty important section. This is going to allow us to do math operations, to logarithmic expressions, and to simplify logarithmic expressions. These properties will also allow us to solve more sophisticated logarithmic and exponential equations. So, some of these properties are they're more just general statements, really, but I'll highlight the big properties that show up a lot, or the ones that are I should say most important, really. But this one's more of a special value more than a property, really. And all this property says right here is if you have a log of base A of 1, you're going to get 0. Or if you have a log of base A of itself, you're going to get 1. This makes sense because a to the 0 power is 1. We already know that. And we know a to the first power is a. We know this, and the equivalent logarithmic statement is what I have typed here. And the natural log of 1 is 0. And that makes sense because e to the 0, anything to the 0 power is going to be 1, just like it is here. And a to the first is itself. So, this isn't a property per se. This is just a special case. And it shows up sometimes when you evaluate logs and exponentials. Property 2. Since logs and exponentials are inverse functions, if you do one and then the other simultaneously, you get what you started with. In other words, they cancel each other out, right? So if you have a base of a raised to a logarithm of base a, of the same base, basically, they cancel each other out, and you're just left with x, which is right here. If you have a base e of natural log of x, the e and the ln cancel out, you're just left with x. The vice versa order is also true as well. If you're taking the logarithm of base a of a base a exponential, they cancel each other out. You're just left with x. If you have the natural logarithm of base e, they cancel each other out. You're just left with x. So basically, if you have an exponential and you take the logarithm of that exponential, they cancel each other out because they're inverses of each other. They undo each other, basically. So to simplify the following, right, I have 7 raised to the power of log base 7 of the square root of 3. All right. Well, since the base of this exponent is 7 and the base of this logarithm is 7, they just essentially, they undo each other, and I'm just left with the square root of 3. That's it. I'm just left with that. They just undo each other. It doesn't matter that this thing is up here. This is a logarithm base 7 of the square root of 3. All right, this square root of 3 is being put into. This is not a power here. If I wrote that a little too high, this square root of 3 is going into this logarithmic function. All right. Same thing here. The natural log of e to the negative 13th power. ln of e, they cancel each other out. They undo each other. The natural log of e, they undo each other, so all I'm left with is negative 13. I could do this one in my calculator. If I took an ln and typed in e to the negative 13, you're going to get negative 13. All right? They undo each other. Nothing surprising there. Now here's the here's some, you know, very common and very important properties of logarithms. Okay. And again, these properties are valid for both base A and base E logarithms. I'm just, you know, I'm re-mentioning that because that is important to understand. These properties are valid for both base A and base E logarithms. I'm going to show the properties using base A, but just remember that this will also work for ln of the same thing. So now these two properties show up a lot. These are very common. Okay? And what this property states is the log of the product equals the sum of the logs. So if you have a log of any base of, you know, m and n here are expressions. Or terms. M and n could be anything. They could be expressions, terms, polynomials, whatever. If I have a log of a product, so that means m times n is in the logarithmic function, I could write it as log of a, base a of m, plus log base a of n. The log of a product equals the sum of the logs. All right? The log of the quotient equals the difference of the logs. So if I have a log of any base of a quotient of two things, like something divided by another, I can write that as the log of base A of the top minus the log of base A of the bottom. Okay? Ooh, that's a typo there. That shouldn't be in there. That should be a base A. Yeah, I gotta change that. All right. I want to emphasize this. I see this a lot. Students commonly get these properties wrong. It's a common mistake to get these properties incorrect. So, for example, you cannot break up the sum of a log. I'll even say this: you cannot break up the sum or difference of a log. All right. If you have the log of base a of m plus n, you cannot distribute like this and get log of base m plus log. You cannot do that. That is a no-no. All right. If you have a log of a sum or a log of a difference in the logarithm, it's stuck in there. It can't come out. The only time you can break it up is if you have a log of a product in there or a log of a quotient in there. You follow these properties. If you have a log of a sum or difference in here, you cannot break it up. Here's another common mistake, where, log of a term minus the log of another term, and you write it as log of m divided by log of n. You can't do that either. This is no either. All right. Logarithms are something that you haven't quite seen yet in an algebra class, unless you've seen them before. So you have to be careful about how you handle logarithms. All right. You have to be careful about logs. When in doubt, just remember these two right here. These are the two you got to remember. The log of a product equals the sum of the logs. The log of a quotient equals the difference of the logs. You cannot break up the sum or difference of a log. All right. This property is also useful. So if you're taking the logarithm of an expression, right? So if you have a log of something, and that something is raised to a power, you could bring that power out in front as a factor. So let me kind of rewrite it again just to show you. If I have log of some base, And in that logarithm, I have m to the r power. So if anything inside the logarithm is raised to a power, I could bring that power out front and write it as r times log base a of m. I could do that. And this is just a product right here. All right. Don't confuse that for this. This is completely different. You cannot do it for this. All right, you cannot do it for that. This one works. That one doesn't. You have to look at the difference here. M to the r power is going into the function. This one here says m is going into the function and the whole expression is being raised to the r power. That is not, you cannot do that. All right. This is what's going on here. If you have a log of stuff raised to a power, so if the stuff in there is raised to a power, you can bring the power out as a factor. You know, this might seem like a lot, but when you start working with the properties, they kind of sink in. Same bases, same base logs have equal expressions. So if you have a log of base a of m equals a log of base a of n, since they have the same bases, their expressions are equal. So if I have log of base a of m, that's an a, not an e, and I have log base a of n, so m goes into that logarithm, n goes into this one. Since they're the same base, I could say then m equals n. All right. So again, these properties kind of, you know, these properties start to make more sense when you start looking at examples. But, and you know, we use them so much that, you know, they become very easy to work with. So in this example, or in these two examples, I say write this logarithm as a sum of logs. Express all powers as factors. Okay. So I have log of base a of, I'll put brackets here, of x squared times the square root of x plus 1. All right. So what's going on here is I have a log of a product, right? I have a log of a product. So you could think of the x squared here as m, and you could think of the square root of x plus 1 as n, in, you know, in the properties that we used. So if I have a log of any base of a product, that equals the sum of the two logs, right? That's going to equal log of base a of m, which is x squared, plus log base a of the square root of x plus 1. All right, where this right here is the m term, and that right there, this whole thing, is the n term. You know, that's analogous to the property we just looked at. Right? If you look at this, the properties as reference, right? The log of a product, m and n, equals log of the first term plus the log of the second term. I just used property number 3 here. That's what I used. Now, my directions here are to write this as a sum of logarithms and express all powers as factors. All right. So if I look here, right, I have the log of base a of x to the second power. So I could still simplify this, right? I have a log of something that's raised to a power. So according to property number 5, right? If you look at your property number 5 for reference, there it is. If you have a log of something raised to a power, that power comes out front as a factor, right? Something to a power in the logarithm, that something comes out front as a factor. So according to property number 5, I could take this 2 and bring it out front as a factor. So I'm going to have 2 times log base A of x plus. Now, this one requires a little intuition, but if you look at this in here, right, this expression, if I think of this as, remember we could write the square root of x plus 1? We could write that as what? X plus 1 to what power? You could write a radical to a fractional power. That's to the 1/2 power, right? So if I rewrite this, if I have log base A of the square root of x plus 1, I could think of this as log base A of x plus 1 to the 1/2 power. Same thing. But now that it's rewritten this way, right? Take this and rewrite it that way. But now that it's rewritten this way, what could I do with this 1/2 power? I could bring it out front, just like I did with the 2 here. I could bring it out front using property number 5 again. So I'll have 2 times log base A of x plus 1/2 times log base A of x plus 1. Now I can't, remember, you can't break this up. This is a log of a sum. You can't break up the log of a sum. That's stuck in there. So, I wrote this as a sum of logarithms, and I expressed all powers as factors, so I'm done. That's how you could use the properties of logarithms to rewrite this expression as this expression. Remember, you cannot break this up. Okay, let's look at this one. Same directions. So I have the natural log. Again, these properties apply to natural log or log log of the quantity 2x squared over x minus 2 to the 4th power. So I'm taking the natural log of that polynomial. Well, that rational, I should say. That rational term. So which property is going to allow me to break that up? Well, this is the log of a quotient, right? That's property number 4. The log of a quotient equals the difference of the logs. So you're just going to write this as, you could think of the top. You can think of the top here as m, and you can think the top and the bottom here as n, right? So this will be ln of the top, which is 2x squared, minus ln of the bottom, which is x minus 2 to the 4th. Now what do I do? Well, you could see again, and we're going to use property number 5 again, right? I have a log of stuff to a power, so that power could come out front. Same thing here. I have a log of stuff to a power. That power could come out front as a factor. So I'm going to have 2 times ln of 2x minus 4 times ln of x minus 2. So, I can't break this one up right here because this is a log of a difference. I cannot break that up, right? Now, technically, this right here is a log of a product again, right? That's a log of a product. So I could break this up again if I wanted to. I could write this as 2 times, now I'm going to put parentheses here. So this is a log of a product again, so I could write that, the log of a product equals the sum of the logs, right? So I could write this as ln of 2 plus ln of x, right? That's for this whole thing right here. And then I just continue, minus 4 times ln of x minus 2. All right, I could write that. There's nothing wrong with that. And that's it. I can't go any further with that. I can't break this up because that's a log of a difference. I cannot break that up. Logs of sums and differences do not break up. Log of products and log of quotients do break up. Yeah. So, if you want to distribute the 2 here, you could. You could just distribute the 2 here if you wanted to keep going with that. There's nothing wrong with that. You could stop here, or you could keep going and just distribute the 2 here and write 2 times the natural log of 2 plus 2 times the natural log of x minus 4 times the natural log of x minus 2. Either one works fine. All right. I do want to make a comment though. If I broke this up right here, like if I wrote this as natural log of 2, like if I broke this product up here initially, there's nothing wrong with that. I could write this as the ln of 2 plus ln of x squared. I could have done that there. I'll get to the same result at some point. I'll get to the same result. Okay. Let's keep going here. These properties, you get better with them with practice, but they can take a little time to get used to, but it's really not that bad. I don't think it is anyway. All right. What if we want to go the opposite way? So what if I want to write this sum and difference as a single logarithm? Well, I could do that. There's nothing wrong with that. So what I'm going to do here is I'm just going to focus on each piece separately. I'm just going to go from left to right. So I'm going to look at this piece first. Alright, so I'm going to have, so the log of base B of this plus log of base B of this, I'm just going to write that. So remember, the log of a sum plus the log of it, that's the log of the product, right? And I could go in the opposite order of this property. So what I'm doing here is I have this, and now I'm going in this direction. So I have this going on right here, and they need to have the same base in order for them to work, right? They can't have different bases. So this, I could say this is log of base B of the product between x squared plus 4 times 4. All right. So that's what these two combine to be. They combine to be this right here. I just use this property number 3, but I'm going in this direction. All right. Now I have what? I have plus log base B of x minus log base B of 7. So now I'm going to look at this right here. I'm going to look at this piece. So I have a log of this plus another log of another term, so I'm going to use the same property again. Those two will become another product. That'll be log of base B of this times that. So that'll be the log of, so it'll be x squared plus 4 times 4 times x. So that'll be 4x times x squared plus 4. That's the same property again. Then I have minus log base B of 7. And now I'm going to use property number 4, right? So I have a log of a term minus a log of another term, so that's going to be the quotient of the logs, right? So that'll be the log of base B of this divided by 7. So by just using the properties in the opposite order, I could just rewrite and get a single logarithm. So these two combine to be that. You know, these properties show up a lot when we're dealing with logarithms, but they just take practice to get used to, really. Okay. The last part of these notes involve using the change of base formula. Okay? So here's the change of base formula. Remember we said in the previous section that we need to use the change of base formula to evaluate logs that are not base 10 in the TI calculator. So here's how we do it. So if you have a log of base A of some number or some expression, you could rewrite it using natural logarithms. You could rewrite it as ln of m over ln of a. All right? That's it. If I have a log of any base of a term, I could just write this as ln of m over ln of a. That's all you need to do. So for example, find the value of log base 7 of 52. Round your answer to 4 decimal places. So, you know, I couldn't do this in my calculator if I wanted to because this is base 7. Your calculator does it in base 10 for logs. So to do it in my calculator, I just use the change of base formula. This is a very handy formula. So you could just write this as ln of 52 divided by ln of 7. Now, do not cancel out the logarithms. You cannot do that. Don't do this. Don't go and get 52 over 7. You can't do that. The log of a number, the log of it, they're stuck together. The log of the expression, they are stuck together. You know, you can't do this. The following. Don't do this and get 52 over 7. No, can't do that. I see that mistake a lot. Don't do that. You can't just cancel out ln. That doesn't make sense. That's like saying you're canceling out sine or cosine if you take trigonometry. All right, so just type those values in your calculator. So ln of 52. So natural log of 52. Close that off. Divide it by ln of 7. And that gives you 2.031. I'm rounding it to 4 decimal places, so 1, 2, 3, 4. So 2.0305. So that's what this would be. You know, what does this really say? Right? If I wrote this as a exponential, this is saying 7 to what power gives me 52. 7 to what power gives me 52? Well, the power is roughly 2.0305. If you did that in your calculator, you would get roughly 52. Right? If you did 7 to the 2.0305 power, you're going to get, it's an approximation, so you're not going to get exactly 52, but you're going to get pretty close to it, 51.99. But we just usually leave it like this. That's the exact value. This is the approximate. That's the exact value. This is the approximate. So, you know, that's what this right here is just saying as an equivalent expression. You have that. So yeah, when you're dealing with properties of logarithms, you know, the big three, that's what I like to refer to them as, is the log of a product equals the sum of the logs. ln of A plus ln of B. The log of a quotient equals the difference of the logs. And the log of something to a power equals R times ln of something. Those are the big three you need to be most concerned about. Okay? So that, that's really it when it comes to dealing with logarithmic properties. But so yeah, they just, they require practice to do that. But what we're going to do in 6.6 is using these properties to solve logarithmic and exponential equations. All right. So that's the end of this video.